3.3 notes, properties of functions, and the difference quotient. This is page 1. So again, we have our objectives up here in this little gray box. Rate of change is the focus here. So average rate of change, you guys mathematically, it's the slope. So slope, rate of change, exact same thing. So we're going to talk about how we find the slope of the line or a secant. A secant is just the line that connects 2 points on a curve. So you notice that there is an active link there. If you click on that in the notes, it'll just take you a page that walks through a definition. This is the equation for slope that you're probably used to. In high school, middle school, we saw it as rise over run. You might also see it as delta y over delta x. Delta just means change. All of those notations mean the exact same thing. Okay, so here's how we find the slope. It's the difference between our y coordinates of 2 points. That's the change in the rise, the vertical displacement. And then that is divided by the change in the x, the difference between the x coordinates of our 2 points. That is the horizontal displacement. Okay, we are going to talk about point slope form of the equation of the line. Probably not something you've seen as much as slope intercept form. I'm going to tell you though, especially moving into calculus, this version is more useful. And you notice it looks a whole lot like the equation for slope. We have multiplied both sides by that x sub 2 minus x sub 1, and then we made our x sub 2 generic. Exact same thing, okay? So it's gonna look like A. We wanna write the equation of the line passing through the points 4, 3 and negative 1, 1. We are gonna start by finding the slope, and I'm gonna go ahead and just write the equation here. So we have it equals, so y sub 2, I'm gonna see if I can keep my numerator positive, minus my other y coordinate. I need to make sure I subtract the x's in the same direction. So if my y is subtracted that way, my x's need to subtract that way as well. Do not let your eyes trick you. We want to make sure that we don't lose the minus because of the negative in front of the 1. We get a slope of 2/5. Okay. We don't have a y-intercept, so I'm going to go ahead and use, let me change colors up just a little so we can differentiate. I'm going to use point slope form of the line. And just run through a couple of examples, show you that it's all the same. The x and the y are our generic xy coordinates. The x sub 1, y sub 1 is a specific point. So I'm going to go ahead and use that first point that we used before. And boom, you know what? That's an acceptable form for the equation of the line. We get y minus 3 equals our slope 2/5 times x minus 4. I could have also plugged in the other point. That would have given me a y minus 1 equals 2/5 times x minus negative 1. And I am going to go ahead and convert both of those to slope intercept. Just make sure I haven't made any mistakes. I get y minus 3 equals 2/5 x minus 8/5. I'm going to add the 3 to both sides. Over here, I'm going to add it as 15/5. And I get, I'm going to go ahead and just slide it over here. Y equals 2/5 x plus 7/5. So that's what it looks like in slope intercept form. Let's try this other one and make sure that I have not messed something up. I get 2/5 times x. This is plus 1, so plus 2/5. I'm going to add 1 to both sides. Over here, it's going to look like 5/5. And I get the exact same thing there. 3 different versions of the equation. They all reflect, or they all are that same, the equation of the same line, even if they look different. Okay. Example 2 is looking for a rate of change based on a table. And so the rate of change describes how our outputs change with respect to the input. In this case, this is the year. So how much gasoline prices have changed over a given number of years. Okay? Understand, because this is real data, the rate of change between any 2 years may not be the same, and it probably won't. So you are going to be left to choose sometimes that rate of change that you feel describes the data best. So B asks for, A asks for gasoline costs, what's Y, what's C of Y. Y here is the year. C of Y is the cost in a given year. Cost of gas. B now asks for the average rate of change for the cost of gas from 2005 to 2012. I'm going to go ahead and write this as an ordered pair. It's a little weird putting Y first, but it reflects the year. And so it's not an XY situation. Y is our input. It reflects that year. And so our average rate of change, I've got the change in the price of gas, 368 minus 231, over the number of years. So we're talking about 7 years here. It changed $1.37. And we know what it's like. That goes up and down. And so we get approximately 20 cents per year, or $0.2 per year. We want to make sure our labels are correct. Now we're going to find 2 other years and check. So let's go, let's try 2006. We have 262. 2009. We have 241. And we look for the average rate of change here. I've got 241 minus 262. Over that, I'm working just to keep my denominator positive. We could have subtracted in the other order. We're still going to be fine. So I get a change of 21 cents, negative 21 cents over the 3 years. So I get negative $0.07 per year, or 7 cents per year. Keep in mind it will be different if you choose a different pair of years.